All right, hello again. We are at the fourth portion or fourth part of the differentiation rules series. For this particular video, we're going to be doing some quote unquote application problems using the derivatives that we've learned so far. And so I have two problems in particular. I have them both up here. And these problems are here to sort of give us a general understanding of some of the concepts that we would be trying to solve for or use whenever we are taking a derivative of a particular function. So let's go ahead and get started with this first one here. So this one says, for what values of x does the graph of f of x equaling, let's see, x cubed plus 3x squared plus x plus 3 have a horizontal tangent line? Okay. So before we even get into doing the computational stuff for this, let's just think about this for a second. We know that we have a function here that is a polynomial, and the polynomial is of degree 3, so that looks like a cubic function. Our leading term here is x cubed, and of course we know that since the leading term is a positive x cubed, if we were drawing the graph of this, we know that its end behavior would look something like this. Okay, so as x approaches negative infinity, the graph of this function goes down to negative infinity, and vice versa. As x approaches positive infinity, the graph goes up to positive infinity. Okay, so without knowing any other particulars for it, one way that this graph could look would be as follows. It could look like this. Okay. So, and here we're asking, when does this graph have horizontal tangent lines? Okay. So if we look here, we see that the graph has horizontal tangent lines whenever we have a peak or a dip in the graph. And in particular, we have horizontal tangent line here, horizontal tangent line there. So we see that there's two places, and of course, horizontal tangent line, if we were taking the derivative of this particular function or instantaneous rate of change at these points here, then that would tell us that the instantaneous rate of change or derivative would be 0 there, because the slope of the tangent line there is 0. So essentially what that's communicating to us, just by looking at the graph of this, we want to figure out for what values of x solves this particular equation, because one of the interpretations for the derivative of a function is the slope of the tangent line at the various points that that particular graph has. Okay, so we're going to solve this particular equation, take the derivative of this, set it equal to 0, and then we'll see what type answers we get. And so we're expecting to have 2. Now, of course, this graph isn't drawn to scale for this, but here this is just to tell us that we are expecting 2 different answers. So, in knowing this, if we need to take the derivative of this function and set it equal to 0, then taking the derivative of f of x, the first term is going to be 3x squared, because of course power rule says we bring down the 3, subtract 1 from the exponent, plus 3 times, here we know bring down the 2, and then subtract 1 from the exponent. The derivative of x is just the slope, which is just 1, okay? And then of course the derivative of any constant is 0. And we set that equal to 0. And so if we clean everything up, make it look nice, we are trying to solve this particular quadratic equation. Now, here, of course, we could do completing the square. We could use quadratic formula. We could try to factor. I can tell you now that just by looking at this, we probably can't factor it, and so I'm going to show you how I know that. If we look at the discriminant for this, And of course, you know the discriminant is that particular expression that's under the square root sign in the quadratic formula. If we do that, of course, our A is 3, our B is 6, and our C is 1 here. If we plug this in, you'll see this is 36, that's 12. So 36 minus 12 gives us 24. And 24 isn't a perfect square. So when we take the square root of 24, that's not going to give us something nice and easy, okay? So that's letting us know that we're going to have two irrational answers there. So we know this. So using the quadratic formula, because that's probably the easiest route to go here, have a minus 6 plus or minus, we already know this is 24, divided by 2 times 3. And so once we work this out, we'll see what the answer is. Of course, 24 is the same as 4 times 6, so we could rewrite this way. And so then from this point, square root of 4 is 2. So if we simplify here, what we'll have is -1 and 6 reduces to 1/3. So we have -1 plus or minus square root of 6 over 3. And so those are our two answers. First answer would be this one. Second answer would be that one. So here, this one would be about somewhere around here. And this one would be a little larger than that. I think, can't really think, let me see right quick. But I think it might be, yeah, something like 1.8, yeah, -1.8. And so, of course, this is negative as well. So if we were drawing the graph of this, then of course, just like how we had it look before, probably looks something to this effect, where places where we have the peak and dip are both on the negative side of the x-axis. Okay?